All right, guys, this is Miss Kaufman and Mrs. Whiteside, and we are back for what may be the last official video lesson for 8th grade.
Whoop, whoop.
Whoop, whoop. Okay, so we have been learning about forces, and we've talked a little bit about balanced and unbalanced forces. And then we began to learn about Newton's 3 laws of motion. And his first law, if you remember, was that an object at rest will remain at rest unless acted upon by an outside unbalanced force. And an object in motion will remain in motion unless acted upon by an outside unbalanced force. His second law had to do with force, mass, and acceleration. And to calculate force, you took the mass of an object and multiplied it by the acceleration. One of the things I believe we also mentioned was that if the mass of an object is really, really big and there's just kind of a medium-sized force applied to it, it's going to get a little bitty acceleration. It was kind of like that. They showed the picture of the guy with the golf club using that amount of force to try to move a truck. Didn't probably work real well. But if the mass of the object is really, really small, like the golf ball itself, and you apply a pretty good sized force to it, then you're going to get a really good acceleration from that. So that brings us to Newton's 3rd law of motion. And this is the last one. This states that for every action, there is an equal but opposite reaction. Action-reaction forces act on different objects while balanced forces act on single objects. And I know when I was teaching about the balanced and unbalanced forces, we used this little cart that was on wheels in my room, and that's because it was a single object. The things I'm going to talk to you about today, though, is going to affect 2 things. Newton's 3 laws of motion will describe and predict motion. The other thing is we're going to have some video clips that are also in today's science event that I would like for you to watch before you finish this, because they are really very good at describing this. Okay, so I asked Miss Whiteside if she wanted me to tell this story, and I tell this story every year in my classes when I'm teaching this, so I'm going to go ahead and tell you this story. It's a story about me. This might be my favorite of Newton's 3 laws, and there's a reason for that. I can remember with clarity the first time I was actually introduced to Newton's 3rd law of motion. And this is how the story goes. It was the summer before my senior year in high school, and one of my buddies and I were horseback riding with 2 guys that were in our class. We were all just friends, but we were riding on horses, and these guys got to talking about how hunting season was coming up soon. And so they asked me if I'd ever shot a gun, and I went, no, I have not ever shot a gun. And I didn't realize it, but at that moment there was an evil plot hatched that was about to occur to me. Okay, now, so you have to realize, guys, I was 17, and I lived in northwest Oklahoma. I did not live in the middle of town. I lived kind of on the edge of town, and where we were horseback riding, the guy that had the horses had, I don't know how many acres of land they had. So I want you to understand, I was not doing this in the city limits. I wasn't doing it where it could have hurt anybody. So I'm going to tell you the story. So they said, well, Debbie, let's just go back, put the horses up, and we'll get the shotgun, and I'll show you how. And I'm like, okay, I will. My friend's like, yeah. So for some reason, they decided I needed to be the first one to try it. So they take me out in the field. My so-called friend, the guy that is in my class, goes into his house, comes out with a 12-gauge shotgun. I didn't know a thing in the world about it. We go out into the field, and he says, okay, you're going to put the butt of that shotgun right here. I'm gonna hold it up with this other one. And you see that limb on that tree over there? Yeah. Okay, raise it up there, and when you're ready, just squeeze the trigger. Okay. So I did that, and boom, I find myself down here on the floor, like not knowing what happened. Okay, I get up, I'm picking stickers out of my behind, and these three people that are supposed to be my friends are about to die laughing. That was Newton's third law of motion. A 12 gauge shotgun.
Ooh, that's a lot of action.
Has a lot of action. Okay? It shoots that shell really, 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 really fast out the barrel with a certain amount of force. But the same amount of force, the exact same amount of force, is going back this way. And guess what?
That's the kick.
I was part of it. Now I know that's called a recoil, okay? That's why I'm saying I got introduced to Newton's third law of motion up close and personal.
I bet you had a pretty bruise on that shoulder too.
Oh yeah, I was definitely not happy with my friends.
When I was in the Navy, we went target shooting and on the range, and this was an old World War II gun that my boyfriend at the time had, and I'd shot before, and he gives it to me. Well, I did not realize how much of a recoil it had. My shoulder was pretty darn sore for several days, and it was a very nice, pretty shade of purple. It's a good thing purple's my favorite color.
So, I like to tell that story because there's not always funny stories to tell about Newton's third law of motion, but that one was definitely funny. My friends thought it was hysterical.
I bet they did.
All right, so this is kind of similar to what I was just describing. This is an old Civil War cannon, and you know they don't have these everywhere anymore, but they do have them occasionally, like when they do reenactments of different battles and stuff. And they load that cannonball, that big old cannonball, into this barrel. They pack it with gunpowder, and then they light that thing. And I don't know if you've ever seen this in an old movie or not, but the moment that ball comes shooting out the outside of the barrel there, you better not be standing behind it, because this whole entire cannon goes back with the same amount of force. Okay, remember that force, mass, and acceleration are all related, okay? So this is a much smaller mass, okay? So force is equal to mass times acceleration. I got that in there weird. If this is a small mass, I'll do that with a little bitty m. How's that? A little bitty m. But a really big acceleration, okay? That's what you're going to end up with when this all happens, because it's all using the same amount of force. That force is going the opposite with the reaction, but this big cannon's not nearly as small as that cannonball. So the acceleration in the opposite direction is proportionate. It's going to go backwards, but not near as far as that cannonball went in the beginning to go the other direction. It's all because of the mass being so much bigger. Every year I usually try to find out if I've got anybody who skateboards. And skateboards are great for demonstrating this. If you can get somebody on a skateboard and get on a pretty smooth surface, can't be like a carpet or anything, like sometimes we do it out here in the hall, and you give them a small mass and ask them to throw it, it's probably not going to move them back very far. But the bigger the mass you get, because that's going to be the action, the bigger the mass of the ball you get, the farther you go back, because that's the reaction. All right. I'm sure there are other ways to describe this, but I think that the 3 videos that we're going to show you in just a minute are going to do a real good job. Okay, thank you.